Why the Russian mega-earthquake didn't cause a tsunami catastrophe. Why was the Russian megathrust earthquake less devastating than expected? Just recently, a colossal earthquake measuring 8.8 on the Richter scale shook eastern Russia, sparking widespread alarm about potential tsunami threats. When this massive quake struck at 11:25 a.m. local time on Wednesday, or 25 BST, fears rippled through coastal communities across the Pacific, echoing the memories of past tragedies like the catastrophic tsunami of December 26, 2004, in the Indian Ocean, and the one in Japan in 2011, both of which followed similarly powerful tectonic upheavals. Fortunately, the aftermath of this quake produced far milder consequences than initially anticipated, leading many to ponder, what exactly triggered this earthquake? What role did the tsunami play? And why did it not inflict widespread devastation? Understanding the mechanics of a mega-earthquake. The Kamchatka Peninsula may be remote, yet it is positioned within the notorious Pacific Ring of Fire, an area recognized for its high frequency of earthquakes and volcanic activity. This geological phenomenon arises from the Earth's upper layers, which are divided into tectonic plates, constantly shifting in relation to each other. The Pacific Ring of Fire encompasses a significant arc of these plates, hosting around 80% of the planet's earthquakes, as reported by the British Geological Survey. Just offshore from the Kamchatka Peninsula, the Pacific Plate moves northwest at an approximate speed of 8 centimeters, 3 inches annually, akin to the rate of nail growth but considered rapid from a geological perspective. This plate interacts with the smaller Okhotsk microplate. The Pacific Plate is composed of denser oceanic rock, which trends to slip beneath the lighter microplate. As the Pacific Plate descends toward Earth's core, it heats up and begins to melt, essentially fading from existence. However, this descent is often interrupted as the plates can become locked together during their movement, causing the upper plate to be dragged downwards. Over thousands of years, friction accumulates, only to release catastrophically in mere moments, a phenomenon referred to as a megathrust earthquake. Dr. Stephen Hicks, a seismology lecturer at University College London, clarifies that when we envision earthquakes, we often visualize an epicenter pinpointed on a map. However, in the case of massive quakes like this one, the rupture spans hundreds of kilometers, resulting in considerable seismic energy release. Some of history's largest earthquakes, including the most notable ones in Chile, Alaska, and Sumatra, are categorized as megathrust earthquakes. And the Kamchatka Peninsula is no stranger to such upheavals. In fact, another powerful 9.0 magnitude earthquake occurred within 30 kilometers, 19 miles, of this week's event back in 1952, according to data from the U.S. Geological Survey. Tsunami expectations versus reality. The sudden movement of tectonic plates can indeed displace vast amounts of water, potentially creating tsunami waves that travel toward the shore. In the deep ocean, tsunami waves can reach speeds exceeding 500 miles per hour, around 800 kilometers per hour, which is comparable to the velocity of a passenger airplane. In these depths, the waves are long and low, rarely exceeding a height of 1 meter. However, as a tsunami approaches shallower coastal waters, it can slow down to around 20 to 30 miles per hour. Here, the distance between wave crests diminishes, while their heights escalate, sometimes forming what appears to be a towering wall of water near the coastline. But it's critical to note that not every significant earthquake results in towering tsunami waves marching far inland. In the case of the recent quake, tsunami waves reached heights of up to 4 meters, 13 feet, in various parts of eastern Russia, an impressive surge, but still a far cry from the monstrous waves of many meters recorded during the Boxing Day disaster of 2004, or the tragedy in Japan in 2011. According to Professor Lisa McNeil, a professor of tectonics at the University of Southampton. The size of tsunami waves is significantly influenced by the local underwater topography and the landscape of the land where they land. These elements, coupled with coastal population density, also dictate the magnitude of the tsunami's impact, she elaborated. Interestingly, initial assessments from the U.S. Geological Survey indicated that the quake occurred at a relatively shallow depth of about 20.7 kilometers, 12.9 miles, beneath Earth's surface. Such a shallow depth can intensify the seafloor displacement and elevate tsunami wave heights. However, researchers caution that solid conclusions may take time to materialize. One speculation is that the tsunami modeling may have overestimated the earthquake's depth, noted Dr. Hicks in an interview with BBC News. If the quake were hypothetically situated another 20 kilometers deeper, the tsunami wave's heights could be drastically reduced. Advancements in early warning systems. A further critical factor in this scenario is the significant advancements made in early warning systems. Given the high frequency of earthquakes in the Pacific region, many countries have developed dedicated tsunami monitoring centers to issue timely alerts and facilitate population evacuations. Unlike the situation during the 2004 Boxing Day tsunami, where no early warning system was available, the deployment of these advanced systems has proven invaluable, potentially saving countless lives. At that time, a staggering number of over 230,000 individuals died across 14 nations surrounding the Indian Ocean due to a lack of warning. Early warning systems are essential, especially considering the unpredictable nature of earthquakes. For example, just 10 days prior to this recent earthquake, a smaller quake measuring 7.4 struck in the same area. While this might have indicated an early release of seismic energy, also known as a foreshock, it couldn't precisely forecast the timing or the magnitude of subsequent earthquakes, emphasized Professor McNeil. She further clarified, although we can assess the speed at which tectonic plates are moving, utilize GPS technology to monitor their current positioning, and study past seismic activities, we can only derive probabilistic forecasts regarding potential earthquakes. Looking ahead, the Geophysical Survey of the Russian Academy of Sciences, GSRAS, plans to maintain vigilance in monitoring this region, as aftershocks could linger for weeks to come. So, what do you think? What are your thoughts on the effectiveness of tsunami warning systems? Do you believe we are doing enough to prepare for natural disasters? Or is there more to be done? Join the conversation in the comments below. Your perspective matters. Tsunami Advisory extended. What you need to know. Hawaii residents, brace yourselves. The tsunami threat isn't over yet. In an urgent update, officials have extended the Tsunami Advisory across all islands until noon today, warning of unpredictable currents and additional waves that could disrupt coastal areas. But here's what's catching experts off guard. This isn't just about the ocean. A rare collision of weather patterns is creating a perfect storm of risks, from raging surf to fire hazards. As trade winds intensify over the next 48 hours, strengthening from moderate to locally powerful gusts, a high-pressure system north of the archipelago is flexing its influence. While windward slopes and mountainous regions will see familiar overnight and early morning showers, a dry, stable air mass creeping over the islands promises to lock this pattern in place through the weekend. Think of it like a weather pause button. Clouds cling to peaks, while leeward areas stay parched. Now here's the twist most beachgoers miss. Those inviting south swells? Today's advisory level waves are just the opening act. A larger, more muscular south swell peaks Thursday, coinciding with rising easterly waves as winds surge late Wednesday. Meanwhile, cyclones churning far to our south continue feeding smaller southeast swells into the mix. A reminder that Hawaii's shores are a battleground for distant storms. But the real controversy? Firefighters are side-eyeing the forecast too. Starting Wednesday, plunging humidity and strengthening winds could push conditions to the brink of critical fire risk. Yes, you read that right. Hawaii faces a rare dual threat of tsunami-churned seas and tinderbox landscapes through the weekend. Are we prepared for a scenario where evacuation routes could be choked by both flooding and flames? As you adjust your weekend plans, ask yourself, when was the last time you checked your emergency kit? Drop a comment below. Are these overlapping risks being overstated? Or is Hawaii's disaster readiness truly being tested? Stay vigilant, stay informed, and keep those devices charged. Mahalo to Hawaii News Now for keeping us updated. This story is far from over.